Welcome to qnawire.
So we have a glass slab and light comes in through here at an angle of 30 degrees, and N1 for air is 1 and N2 for glass is 1.523. And first thing we're going to do is we're going to find where would this light go and strike if it was not refracted. So if this angle is 30 degrees, then this angle is also 30 degrees, and we are trying to find this distance x, given that the thickness of the glass slab is 6 millimeters. So in this right triangle, 6 is the adjacent and x is the opposite. So we have tangent of 30 degrees is equal to x over 6, and that gives me x is equal to 3.46 millimeters. So the next thing we need to figure out is where does this light actually go and strike. Now, because of the refractive index of glass, light will be deflected and it would actually go and hit some point, and that point would be at the distance x prime. So next thing we want to do is we want to figure out what is x prime. So we redraw our diagram, and we have the same incident light at an angle of 30 degrees. And what we want to do next is we want to find the angle of refraction. So we want to find this angle theta 2. So N1 sine of theta 1 is equal to N2 sine of theta 2. So N1 is 1 because it's air, and sine of 30 degrees is equal to 1.523. That's the refractive index of glass times sine of theta 2. So solving for theta 2, we get theta 2 is equal to 19.2 degrees. So what that means then is that this x prime here would be equal to 6 times tangent of 19.2 degrees. So x prime is equal to 6 tangent of 19.2 degrees, which comes out to be equal to 2.09 millimeters. So we can now redraw this diagram. So this is what's going on. We have the light coming in at this angle. If it had not deflected, it would have kept on following this path, but this has actually deflected. And then when it comes out of the glass, it will become parallel to the original direction. So we just figured out the x and x prime. So we can now find this distance here. So we can call this distance as L. So L is equal to x minus x prime, and that would be equal to 3.46 minus 2.09, and that comes out to be equal to 1.37 millimeters. But then we are interested in finding this distance d here, the perpendicular distance between them. So this angle here is going to be 30 degrees in this right triangle. L is the hypotenuse, d is the adjacent. So we can say cosine of 30 degrees is equal to d over L, or in other words, we can say d is equal to L times cosine of 30 degrees, which is 1.37 times cosine of 30 degrees, which comes out equal to 1.19 millimeters. So the two rays would have a distance of 1.19 millimeters between them.